So welcome to this short presentation on the assessments for Forensic Geoscience, FSC 30013. Okay, so this module is split into three assessments. So assessment 1 is 50% of the module. It's a group-based report involving an outdoor practical and then working that data up into making a report which one of you needs to submit. So that deadline for this is depending upon when you're doing the survey itself, because obviously there's a lot of you, so you're going to be doing it in different weeks. And to be fair to all the students, it's the same deadline after the actual practical. Assessment 2 comprises 25% of the module mark. This is an individual trace evidence report where I've collected the data for you. You'll then be interrogating it and then working it up into a report and submitting that at the end of in Wednesday on week 9. And then assessment 3 is also worth 25%. This is an individual literature review of a forensic geoscience topic of your choice, which I'll talk about in a minute, in the format of a SWAY, Microsoft SWAY resource. And again, submitting to the VLE, but this time in week 12. So assessment 2 is going to be an individual trace evidence report. And you've got various tasks to do, which I've listed for you here. So initially you have to do a death study of Keele Church graveyard, and there's a few ways of doing that through some data already available of it through either Digimap or others, which I'll talk about in a second. I've also managed to get some burial records for you, so going back at least 500 years. I've also collected some graveyard soil samples for you, which you'll need to work out the locations from, which again I'll talk about in a moment. We've already analysed the soil for you through the PXRF meter. And then once you've done that, it's up to you what you choose to do your report on. So you may decide to look at a particular heavy metal element, for example. Does it vary in the graveyard in concentrations with depth or a distance from the church, for example? Or you could do something else. You could look at calcium, for example. Imagine there's a lot of bodies being buried there, or is the values higher there than in the control samples we've taken off-site of the graveyard. You're then going to bring your data together. You're going to generate the plots and maps, tables and graphs, and then write your individual reports with the deadline of that being in week 9, Wednesday at 1 PM. You'll submit that via the VLE, of course. So death study, that's what you do before you go in the field. You'll have done a little bit of that, I guess, in your first assessment, is to look at some maps. So for example, the current maps of the site, maybe historical maps to see what changes have happened over the area. You could look at things like aerial photographs or land satellite data from Google Earth Pro. You can maybe look at what the soil type is and the bedrock, the geology type and all that. And a lot of that's freely available if you're a higher education student through something called Digimap. So I have made a little death study video of how to do this. So this video I've just stuck up gives you some different examples of how you can extract some information on various sites that you're looking at. Quite topical. Some of that won't be of interest or relevant. For example, buried utilities may be less exciting, but again, it gives you sort of the different data sets that are out there if you're doing some site investigation. So certainly geotechnical world, where a lot of graduates go, in my area, it's really important that you do this properly.
Hello.
Burial records, as I mentioned, I've managed to get them back maybe 400 or 500 years. It's been a burial ground for a lot longer than that, over 1,000 years. There's a Knights Templar church meant to be on site back in the day, and there's also, if you notice, a lot of yew trees growing there, which is sort of where pagans used to bury their dead, which is what, when they converted to Christianity, they tended to keep the yew trees in the graveyard, presumably to encourage the faithful to use it as a burial site. So we've got some information there. Again, you could have a look at the burials, how many numbers there are, what sort of periods did they bury people in. So again, that's there for you. There's also other sort of information out there. So the closest borehole, where they've dug down basically and looked at what the actual ground type is. You can get that from the British Geological Survey. I've already taken the liberty of downloading it for you. It's on the VLE for you, but if you wanted to look at find it yourself, there's I've put the direct link there for you if you want to. I've also done some work as well collecting data. So there's a drone image on the bottom left, or basically a composite image of a lot of drone photos taken on site over the winter for looking at that, looking at the frost there. So again, you could have a look at that if you wanted to, just to show you some examples of the graveyard. I've also got some images of us collecting, or some previous students collecting soil samples using a soil auger for you to look at if you're not aware of how that works. Once they've collected the samples, we've dried them, sieved them, and then you put it through this sort of 10-ton mangle thing to create these soil pellets, which is what you can see here, with the different numbers on representing different sample locations. So they've been dried again, I think, in the oven, which is why they're on those little metal plinths. And then you use these soil pellets, you analyse that through the portable XRF, or you can do it in the field or in the lab. For whatever whatever elements you want to characterize. So the key file on the KLE is this St John's, because that's the church, in Keele Church, XRF final data set. So you'll notice in this data set there's a lot of different tabs. So working from left to right, the first three are measurements of elements measured from the top 25 centimetres, then 26 to 50 centimetres, then 51 to 75 centimetres. So each of those soil augers we've divided into three, and then we're sort of combining that soil into those three data sets. So you can actually, those are the sort of depth data sets, if you like, that you can see varying concentrations of elements with depth. The distance and average tab, the next one over, that's I've calculated each sample location with distance from the church. So again, if you wanted to look at, do concentrations differ with distance? There's some anecdotal evidence to suggest that the more penitent the people are, the closer to the church you are. So sometimes in the past you paid more to get buried closer to the church. So you'd expect a higher burial concentration next to the church. Of course, you'd also get bits of, I don't know, building material falling off the church. So it could be that higher values may be due to those building materials. So anyway, you're not sure, but there's that data for you if you wanted to interrogate it. Moving sequentially right again, there's a control tab that's measuring elements not in the graveyard, so you can see what the background soil concentrations are like. That's quite important. There's the next one across that I've highlighted now is measurements in the lab. So the soil pellets have been taken in the lab and measured. That's what that tab is. The next one across from that is there was a grave being dug by the grave digger when I was collecting the data, so we managed to collect some samples down the side of the empty grave that he was digging from the north side, I think, and that's what that is. So we've got different samples measured or collected down the grave, so that's quite cool, so we can expand our depth information. The next tab across is in situ measurements, so this is where we've just cleared the grass and I've just measured the sort of surface soil with the XRF instrument. So that data is going to be more varied, but it's going to be measured on site. Does that vary between the sort of processed soil samples, I guess? And then I've tried to plot surface versus lab is the last tab. So there's a lot of information in there, and I'm not suggesting you use all of it, but you can use selective parts of that depending upon what kind of aim you want. So if you just wanted to pick, I don't know, calcium over the graveyard, you could use sort of merge all the data sets. If you just wanted to look at variation of certain elements in depth, you could just use those ones, or you could do the distance one, for example. So it's up to you what you use on the data set in there is key. And also notice there's sort of the collected data, and then there's a corrected version. So you want to use the corrected one because that's been corrected versus the control samples that you use to calibrate your results, if you like. Notice also for each sample there's a sample number. There's the sort of easting and northing, that's the sort of location of each of the data sets in there. And I've also done a little bit of stats on average values, standard deviation, maximum minimum values. That's what those bottom sort of columns are likely to show you. Hope that's helpful. So some data you can then work up if you like, and you can put it into graphs in Excel, or you can be more fancy and you can plot them as sort of in a map view, such as this example from a published data set looking at I think this is arsenic levels in drinking water, and you can see they've coloured them and sized them depending upon the concentration. So obviously small dots and blue values it's not so bad, and big circles and red values means that's pretty contaminated. So again, you can do that sort of thing quite easily in ArcMap, the software that we've got free access to at Keele. And how do you do that? Well, I've done a YouTube short version, the link's there, of how to use your ArcGIS skills to put that into concentration. So do have a little read about that if you want to. Okay, so when you've finished all that, you've got all your diagrams and maps and tables, you've got sort of a plan, you've read some background references to look at to see what variations there are, what your results look like. You then have to write your report. So it should be a maximum of 1250 words. Obviously, it needs to be diagrams and illustrations in there. Again, there's guidance and marking criteria, and I've given you a sort of structured, idealized structured report looking at something like this, with the different subsections that you need to be putting in. So don't forget, you need to have a clear, explicit, written down aim and objectives, which you then need to directly refer to back in the discussion, and then maybe find some references to see what other people have found. Is it the same or different, and why that might be? That'd be quite important, backed up with the results that you've used, and again with those sort of lists of things in there is what we'd expect in this assessment. There's plenty more advice on the KLE guidance in there. You know, you need to submit a digitized report in PDF format on the deadline that you were given. There's all sorts of other things in there as well for you to little read and enjoy. So as I say, guidelines are all there for you to help you structure your report, and then trying to give you some information on what each subtopic area should include. That should help you, hopefully give you some advice on each of those areas. And as usual, the marking criteria is there to help you make sure you've covered everything. You've got all the sections in there, and again, that's going to form the basis of your feedback. So hopefully that will be useful information for this assessment.